Good morning, guys. Good evening. Guys, as you all know, that we are going to start our second lecture for the signature system revision, and it may be new for few of you, but it is kind of revision. So I have taken the full course on the signature system. So I will be taking the same notes so that you will get almost the full course content in the less class, less duration. So these are the classification of the signals. So we had discussed the all type of signals like rectangular signal, triangular signal, unit step, unit impulse. All these signals we discussed, and now we have to discuss that which are the type of signals. So this is the continuous time signal, and this is the discrete time signals. Okay, this is continuous, this is discrete. So continuous time, discrete time signals, and then deterministic and random signals, causal, anti-causal, non-causal, and then we have even symmetry, conjugate symmetry, periodic, and energy. So basically, if you talk about the gate exam point of view, then this and this and these three type of signals are very important. That how do you know that which are the signals are causal and non-causal? So these are the signals which are important. So you have to take care of that. Means these three types we have to mainly discuss, and it is also not required for communication point of view. But yes, you should go for it as per the signals. And in the fourth number, you can also give the importance to the even symmetry and non odd symmetry signals. That also you can have importance to this. One second. So there is a little bit gap over the classes. So I hope that you have revised all the previous session. Like first lecture, you have to revise, and if you should not, then at least revise today. So we will go for the deterministic first. So deterministic signals are those signals which are which can be expressed mathematically. So these are the expressions which can be represented by mathematical equations. And deterministic signals are predictable signals. And analytical mathematical theory is utilized for analysis of deterministic signals. And if I talk about the random signals, so in the random signal, we cannot determine it by the mathematical expression. It is unpredictable, and the probability theory is required to understand the random or to analyze or to see the behavior of the random signal. We need a probability. So these are the causal, anti-causal, and non-causal, which is important. Anti-causal signals are those signals which are for t less than 0, the signal is 0. The causal signals are those signals which have the 0 signal for t less than 0. For t less than 0, there is no signal present, and for t greater than 0, there should be a signal. So this is a right hand signal always. An impulse signal is exceptional for the causal signal, because impulse signal is only present at the t equal to 0, but still it is a causal signal. Anti-causal signals are just opposite to the causal signal. Causal signals are for t greater than 0, so it is for t less than 0. For t less than 0, if the signal is present, then we will call it as an anti-causal. So obviously for t less than 0, it is always a left-handed signal. And non-causal signals are those signals which have the both side, like positive and negative side. Both side, if the signal is present, then we call it as a anti-causal, non-causal signal, like a double-sided signal. If you take the time reversal, in the last class we discussed about the time reversal property also. So if you take the time reversal of the causal signal, you will get anti-causal, because the left hand side become right hand side. If you suppose multiply the causal signal with the non-causal signal, the signal become causal, because the signal is only present in the right hand side for a causal signal. So when you multiply, only the right hand side signals will get multiply, and you will get the only right hand side signal. So it is a causal signal. Causal versus anti-causal. So here non-causal multiplied with the anti-causal, you will get anti-causal, because now if you suppose multiply these two signals, so this is left-handed signal and it is having the left-hand side. So when you multiply these two, you will get this part of the signal. That means non-causal. So that is, sorry. Yeah, so we will get only left-hand side. This part of the signal, that means only left-hand side. So only left-hand side means anti-causal. And if you suppose multiply the causal with anti-causal, that is causal with anti-causal, then you will get both sided signal or 0. When you multiply, this will get 0. Okay, when you multiply, this will get 0. Because one is the left hand side, another is the right hand side. So when you multiply, these two will get 0. When you add these two, you will get non-causal, because when you add the left hand side and the right hand side, both signal will come. So you will get non-causal signal. Okay, so this is the example of causal, anti-causal, and non-causal signals. Now, the second most important one is periodic. As I told you, that periodic signals are those signals which repeat themselves after a certain time duration. So like you can see that the signal is starting from here, then it is repeating itself by after 1 second. So these signals are known as periodic signals which repeats themselves after a certain period of time, after a finite duration of time. Then it is called periodic. The finite duration of time after which the signal repeat is called period. So what is the time period of this? So time period of the signal is 1. The signal must exist between minus infinite to infinite. If a signal is periodic, then it should also exist between minus infinite to infinite. You cannot say a signal is periodic when if it is not defined up to minus infinity to infinity, because um, maybe after some time, after infinite time, it is not repeating themselves. So for a signal to be periodic, the signal must exist between minus infinite to infinite. So if the t is the fundamental period of the signal, like then 2t, 3t, nt all will be the period of the same signal. The smallest possible value is called the fundamental period. The smallest possible value of the period, like here we are saying the 2t is also period, 3t is also the period, nt is also the period of the signal. So what will be the smallest one? The t will be the smallest one. So that is known as fundamental period. And reciprocal of the fundamental period is fundamental frequency. For a signal to be periodic, it is existing from minus infinite to infinite. Like for the first signal, this is the signal which is drawn here. You can see that the signal is repeating themselves after 3 seconds. They are starting from this point, then they are repeating after this point. So this will be the time period. Here, what will be the period? This signal is starting from here, and signal is again repeating from this side. So this will be the time period, which is 2. Now, how do you get the fundamental period? Let's see the example. Let x of t is equal to sine 2 pi t by 3. What is omega? Omega is the coefficient of t. The coefficient of t is 2 pi by 3. So this omega is 2 pi by 3. T is equal to 2 pi by omega. And omega is equal to 2 pi by 3. You will get t is equal to 3 seconds. Okay, you will get t is equal to 3 seconds. Now, fundamental period is 3 seconds and fundamental frequency is 1 by 3 hertz. Similarly, the fundamental period of this type of signal, j e to the power j omega naught t, this is written as t, coefficient of t is omega, so this is 10, so 2 pi by 10 is equal to pi by 5. That is the fundamental period of this signal. Now, is the signal x of t cos of 5t ut periodic? So answer is no. Why? Because the ut exists only for the positive side, that is t greater than 0. And this signal is right-sided signal, hence non-periodic, because we said that if the signal is periodic, then it must exist between minus infinite to infinite. So it should exist for all the time. But because this signal cos 5t is multiplied with ut, it is making the signal only right hand side. Because this, if suppose it is cos omega t alone, then it is periodic like this. This is periodic. But this signal is multiplied with ut, which is only positive side. So after this multiplication, this signal will become only due to positive side. So this will become like this. So this is non-periodic because it is not existing for minus infinity. This is your homework. Okay. Now, addition of the periodic signal. Suppose there are more than one signals which are periodic. Suppose there are more than one signals which are periodic and they are added together. So if we add the two signals x1 and x2, and if we want to find this combined signal is periodic or not, okay, we want to calculate this combined signal is periodic or not. So a signal x of t, that is a linear combination of two periodic signal x1t, which is having fundamental period t1, and x2t, which is having the fundamental period t2. Then what you have to do, in first calculate t1 and t2 and then calculate the ratio of their time period should come rational number. What do you mean by the rational number? So rational number means like 10 by 3, 3.3333. So we can represent it in the terms of fraction, and it should be repeating, then it is called rational number. If you suppose divide and it is terminating, means after division you will get fixed value like 2.5, 2.8, 2.9, whatever it is. But if it is completely divisible, so then it is called terminating. So that is also called rational number. What are the irrational number? Where the under root terms come, and pi by 3 comes, e comes, the log e base natural log base e, right? So that e, which is having value 2.7, which is does not repeat. Any value which is under root, inside the under root they don't repeat. And pi by 3, where the pi is included because the pi themselves does not repeat. So these all are called irrational numbers. So if you suppose calculate the time period and these terms comes in your fraction or ratio, then you will call it as an irrational number. So to calculate, if suppose it is periodic, if suppose there is a periodic signal, so for a periodic signal, how do you calculate the fundamental period? The fundamental period is calculated by LCM of numerator of T1, T2 and HCF of denominator of T1, T2. LCM of numerator of T1, T2 and HCF of denominator of T1, T2. Okay, just look at this once and then let me know if you suppose have any doubt, then we will solve questions related to the periodic signal, then you will understand it better. All right. Then see, if you suppose scale any signal, then what will be the effect in the time period? We have seen the signal operation. So suppose this is the signal which is a square wave and it has the fundamental period 4, right? This is the signal starting from this point and they are repeating here. So this has the time period of 4. Okay. So now if I scale it by 2, that means 2t means alpha is 2. So we will divide the whole axis by 2. Okay, so we will divide it by 2. So it will become 1, it will become 2, it will become 3. So this point will come here. This will be coming here. So here you can see the time period is now 2. The time period is 2. So we can say that it is t by alpha. If alpha is the scaling factor which is greater than 1, then the time period gets reduced. So if x of t is periodic with the time period t, then x of alpha t will also be periodic with the time period of t by alpha. The time period will get reduced if alpha is greater than 1, if the time period will increase if alpha is less than 1. Now the same procedure you can apply for integer also, or discrete signal also. If x of n is periodic with the period n, then the period of x of alpha n will be n by alpha if n by alpha is integer. Otherwise it will remain n if n by alpha is not coming integer. Like okay, like this, suppose there is a signal, okay, and it is 1 for all the time, like 0, 1, 2, 3, -1, -2, and so on. If x of n is, if you suppose draw x of 2n, then what you will do, you will divide it by 2, 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 like this. But when you divide it by 2, it will become 1. When you will divide it by 2, it will become 0.5. So 0.5, we cannot represent the 0.5 in the discrete time. In the 0.5, the value will be 0. So 2 by 2 become 1. So 2 by 2 become 1. Okay, this has the value 1. So this value is also 1. 3 by 2 become 1.5, which is not present. And now suppose here it is 4. So here also it is 1. So 4 by 2 become 2. So it is also 1, like this. Similarly, here you will divide it by 2. It will come -1. Like this. So this is x of 2n. Okay, this is x of 2n, which is periodic. So the time period here is 1. The time period here also is 1 because the signal repeat themselves after 1 second. So because the n by alpha was not integer, we are getting time period as the same as the previous one. Here also n equal to 1 and here also n dash equal to 1. So the time period is not changing. Okay. So here you can see when I will draw this, I'm not going to get any other value. It is same signal. But if it is integer, then it will get half. Okay, if it is integer like 0, 2, 4, like this, 0, 2, 4, and 6, like this. This is your signal x of n. And then suppose you are drawing x of 2n. Then 0 divided by 2 is 0. Okay, the signal is here. 2 divided by 2 become 1. 4 divided by 2 become 2. Like this. Minus 2 divided by 2 is -1. Like this. So this time period is now n dash. N dash is equal to 1. And here n is equal to 2. So the time period gets half because now n by alpha was coming as integer. Now you can see that there are two signals. This is 3 sine 4 pi t, which is x1, 7 cos 10 t is equal to x2. So we will find the time period of individual signal like 3 sine 4 pi t. Omega is 4 pi. So 2 pi by 4 pi is 1 by 2. Fine. Now we will calculate the time period of the second signal where the omega is 10. So 2 pi by 10. 10 is pi by 5. Right? 2 pi by 10, so that will be pi by 5. When I will calculate T1 by T2, it is coming as 5 by 2 pi. So if the pi is present, it is called irrational. So if it is irrational, so this signal is not a periodic signal. So it is not a periodic, so no need to calculate the time period. If the signal is not periodic, then no need to calculate time period. Now we have to match the following. Now the first signal, we have to tell whether it is periodic or not. If it is not a periodic, then it is aperiodic, and if it is periodic, then what is the period? So sine 2 pi by 3, omega is 2 pi by 3. So when we divide it 2 pi by 3, then it is coming as 3 only. So time period will become 3. So first signal has the time period 3. Second signal has the combination of 2. Okay, so first we can calculate the third one. Here the 2 pi by 3, so it will come as time period because this is only single signal. So we don't have to see whether it is a rational or not. Okay, when the signals are combined, when there are more than one signals, then you calculate the uh, time period of the combined signal. But it is only signal which is sinusoidal. So sinusoidal is always periodic. It can have any period. So the period is 2 pi by 3. And F4 is equal to F1, which is our first, and minus 2 F3. So the combination of P and R. So it has the time period. First one is having the time period 3. Second one is having the time period 2 pi by 3. So when we divide it, we are getting 9 by 2 pi because the pi is present. So it is irrational, so not a periodic signal. So last one is not a periodic signal. So obviously the Q will be 15. Q will be 15. Now this one you can calculate. How do you calculate this? Again, you can apply the cos A cos B formula, cos A sin B formula, and A plus B, A minus B you can apply, and that will become your more than one signal, that is combination of the signal. So if there is a combination of signal, you just need to take the time period of individual and then calculate its ratio. If it is periodic, then take LCM of numerator and HCF of denominator. This LCM HCF formula here you can see. This is a periodic signal. It is a gate question of 1 mark. So there are three different signals. First signal 30 sine 100t, 10 cos 300, and 6 sine 500. This is having the time period 2 pi by 100, which is pi by 50. Second one is 2 pi by 300, which is pi by 150. 2 pi by 500, and this is pi by 225. Now we have to calculate the whether they are rational or not. So you can check T1 by T2, T2 by T3, and T3 by T1. All these are coming as rational. T1 by T2 is coming 3, it is rational. T2 by T3 is 1.666, repeating, that means rational. T3 by T1 is terminating because it is exact cancelled. Pi and pi will get cancelled, and this is 100 by 5, which is nothing but a zero point 0.2. So it is also rational. So it is terminating. So if it is rational, then we have to just take the numerator, LCM of the numerator. So in the numerator of all the three, we have 2 pi. So LCM will be 2 pi. What is the HCF? 100, 300, 500. What is the highest common factor? 100, 300, 500 common, highest common factor. So that is 100. So 100, 150, sorry, 100, 300, and 500. So 135. Ratio is 135. So highest common factor is 100. So 2 pi by 100, we are getting 100 only, 100 radian per second. So answer is 100. And out in this, this is a discrete time periodic signal, which is having the time period like n. So the signal is repeating from here. The condition for the discrete time signal to be periodic is very much similar, but here it is 2 pi by omega, and this omega is uh, this ratio should be in rational number, and because the time period here is integer, so the n is also integer, and to get the value of n you have to choose the k such that the n is integer. K is the smallest integer so that the n is also integer. We have to make the n integer because this time this is a discrete time sequence. So in the discrete sequence we cannot have the period in the fractions. So we have to take the value of k as a minimum integer which can cancel, which can make n integer. Like the same method is applied in the addition or the combination of the signal x1t and x1 to x2t. Similarly here x1n and x2n. We will calculate the time period of individual signals, and then we will take the HCF. Sorry, LCM. LCM we have to calculate n1 and n2 because it will always be integer. So there is no denominator. when you are multiplying with m1, m1 is the smallest integer which can make the n1 integer, so they will not be coming in the fraction. So if they are not coming in the fraction, then there is no need of calculating HCF of denominator. There is only LCM. There is only LCM. Like here you can see, if this is sine, then the sine is we can think that the sine is a periodic signal, but in the discrete time, you will see that when the sine 2 pi, sine 2n is only written, then we will first calculate the 2 pi by omega, and omega is 2, so we are getting pi. Pi is a rational number, irrational number. So because it is irrational number, so it is not periodic. Now check this one. This is also discrete time signal. So here we have a cos pi n by 9 and sine pi n by 7. This 1 by 2 is no use. So here we will calculate 2 pi by omega. Omega is pi by 9. So we will get 18m1. Pi will get cancelled, we'll get 18m1. So to make n1 integer, the minimum value of integer which we can take is 1, because this is 18 times. So 18 is integer multiple. So no use, no need to take m1 any other value. It will give us minimum integer or minimum period. For here it is 14m2, so n2 is 14. So we have to take the LCM because there is integer value, and we have these are the signals which are a combined signal. So for a combined signal, we have to take the LCM. So when we take the LCM, we will get 126. So the period of the signal is 126. Like here you can see, this is another example. X of n is equal to 2 into e to the power j 5 pi by 4n and 4 e to the power j pi by 4n. n1 is 2 pi 5 pi by 4, we will get 8 by 5 m1. Now if I take m1 1, then this will come as a fraction value or decimal value, which is not possible. So that is why you have to choose m1 such that this n1 become integer. So what we will choose, minimum integer 5, so that this 5 will get cancelled. So m1 is 5, n1 is 8. Similarly here you will calculate 8 m2. So this m2 is because multiple times of 8, which is integer, so m2 you can now take 1, because here nothing we need to cancel. So N2 is 8. Now you will take LCM. When you will take LCM, you will get 8. And if suppose in the same question, I ask you to calculate y of n is equal to x of 3n, then n by alpha is not an integer. Okay, we have seen that in the discrete time signal, if the n by alpha is integer, then the period is divided by alpha. But because the n by alpha is not an integer, so period will remain same. So previously also it is 8, and after the scaling x of 3n, it will remain 8. Now, if suppose you will get some random signals for which you cannot calculate the omega directly, because we have learned that the period of the signal can only be calculated if we have omega, whether it is a continuous time or discrete time, because omega t is equal to 2 pi by omega. So we have to calculate omega first. So if suppose by looking into the question, you are not getting the information about omega, then try to draw the diagram. If you will draw the diagram, you will get the signal period directly from the diagram, and the time period is the signal. Time period is the value after which the signal it repeats themselves. So if I suppose minus 1 to the power n, if I have, and if I suppose put the different values of n, then I am getting 0. At 0 we are getting 1, minus 1, 1, minus 1. At 4 again we will get 1, and then 5 again we will get minus 1. So alternate plus minus, so the time period will become 2. And because this is alternate plus minus, so time period is 2. Now you can see by yourself that which is the time period of the signal. So the signals are repeating from here. The time period is 2. Now, this is another example where you can draw the signal cos pi n square. So when you will draw for the different value of n, like n equal to 0, cos 0 is 1, n equal to 1, it is minus 1, n equal to 2, it is 1, n equal to 3, it is minus 1. So again, these are repeating after 2, so we will say n equal to 2. Then here it is cos pi by 4 n square. So I put the value n equal to minus 1, 0, 1, 2, 3, 4, and so on. So I got the value of n equal to 4. You cannot decide like x, and you here you will observe it. N equal to 0 we have 1, and n equal to 2 we have minus 1. Then n equal to 4 we have 1. So when you will check when you will see the repeated value, then its previous sample and the next sample both should repeat. So n equal to 4, I am getting the same value as x, n equal to 0. So I cannot directly say n equal to 4. If it is periodic, then x of minus 1, that means the sample which is just before x of 0 should also repeat. So that means x of 3 should also have the same value as x of minus 1. X of minus 1 is 1 by root 2. So x of 3 is also 1 by root 2. Now we can be sure that yes, if the present sample and the past sample both are repeating, so maybe the signal is periodic. So we can calculate and take. We can calculate the period of the signal. Wait. Okay. So wait for a few minutes. I will upload the next slide. So we have learned the periodic, non-periodic, and causal, non-causal. Now we have to learn the energy and power signal. Remember that you have to, you will get all this PDF directly. So I am directly teaching you from the PDF, not writing anything because we have to finish in the less time. So we want to, complete the whole syllabus of the signals and system in the uh, maybe in the 3 to 4 weeks. So it would be a little bit difficult for me to cover everything in the short period of time, because now you are having less time. You join a little bit late, so we will be telling you by these PDFs. So if suppose you have find any difficulty, you can just put in the comment section, and otherwise this PDF you will directly get from the drive, and the same PDF I am explaining, so that you will not get you will not face any problem. And the same PDF is for the full course, and in the full course I taught around 40 hours, and the whole syllabus I covered around in 40 hours. So the whole PDF you will get a complete PDF for those 40 hours, and it is now up to you that uh, how much you put the effort to get the all to understand the all 40 hours lecture in the 20 hours. So how do you calculate the power of the signal? So power is nothing but a x squared, that is instantaneous power. And if you suppose want to calculate energy, then you have to integrate the signal from minus infinite to infinite. And if you suppose want to calculate the power, then in the time period, because the periodic signals are power signals mostly, so the time average of the power signal is P average is equal to limit t tends to infinity 1 upon time period integration over the time period, because it is a periodic, so we have to integrate only during the period of the signal, and x of t mod square dt. So in the discrete time, the instantaneous power is x square n, and average is n equal to minus infinity to infinity x of n mod square, and the time average power is n tends to infinity 1 upon 2n plus 1. Why we are taking 1 upon 2n plus 1? Because in the discrete there are one extra term which is present in the zero. The example is given here in the side. Minus 2, minus 1, 0, 1, 2. If you are integrating from minus 2 to 2, then how many terms will come? 5 terms will come. Because minus 2 to 2, if you will see, then it is like a minus 2, minus 1, 0, 1, 2. So there are total 5 terms. So how do you write it? So 2n plus 1. So that is why we are getting one extra term over here. So that's why we write 2n plus 1. Now, a signal is said to be energy signal if its energy is finite and power is zero. If the energy of the signal is finite and power is coming zero, then the signal is said to be energy signal. And a signal is said to be power signal if the power is finite and energy is infinite. A signal is said to be power when the power is finite and energy is infinite. Remember that the finite means it could not be zero, it could not be infinity. It should be between 0 to infinity. Here you can see that there is no equal to sign. Okay, there is no equal to sign. Now the important points about the energy and the power signal. All the finite duration signals are energy signals. All the bounded exponential signals are energy signals because they are not periodic. Both sided exponentials are also energy signals. So exponential signals are energy signals. Bounded signals are energy signals. Energy of the finite duration signal is finite and energy of the power signal is infinite. Periodic signals are generally power signals. Most of the periodic signals are power signals. And a signal cannot be both energy signal and power signal. It is not possible that for the same signal energy and power is finite. Not possible. Okay, think of it once. This is the question. Like a bounded signal, x of t e to the power minus 80 ut. For e to the power minus 80 ut, energy is 1 upon 2a. How? So this is what you can see. How I am calculating the energy. The energy of the signal can be calculated from minus infinity to infinity x of t mod square. So if I square it, because ut is there, so it will be limit of the integration will be 0 to infinity, because ut exists only for 0 to infinity. When you square, you will get e to the power minus 280. After calculation of the e to the power minus 280, you will get 1 upon 2. Simple. Now bounded exponential, this is left hand side, e to the power 80 u minus t. So this also has the 1 upon 2a. Now both sided, if it is exponential but both sided, the energy will get double, because this side is having energy 1 by 2a, this side is having energy 1 by 2a. Both you will add, you will get 1 by a. Now it is unbounded. Here you can see this is not a finite duration signal. So its energy is infinite because the amplitude is continuously increasing. So unbounded signal will have an infinite energy. This is also unbounded because it is going negative side. Amplitude is very, very high. So when you square it, it will become very, very high. So energy tends to infinity. Okay, this is very simple question. Like this is 5. Previously it is 1 by 2 a was coming, so 1 by 4 was coming already. Okay, e to the power minus 2t, e to the power minus 2t ut was having 1 by 2a. So a is 2, so 1 by 4 it is coming. Now you are multiplying with the 5. So when you multiply with the 5, when you calculate the energy, you will take mod square. So when you will take mod square, this 5 square will come. So 5 square means 25. So this 25 will come extra. So 1 by 4 was coming already and this 25 is multiplied. So this is 25 by 4. Okay, so here also I have written e to the power minus alpha t ut has the energy 1 by 2 alpha. If you multiply with k, the energy will become k square. The energy will become k square times of the previous energy. This is unbounded, so energy is infinity. This is finite duration, bounded exponential, so energy will come. So this is 1 by 6 because of this. E to the power 3t ut is 1 by 2a, so it is 1 by 6. And 10 is square, that is 100. So 100 by 6, which is 50 by 3. Unbounded, energy infinite. Bounded, energy 1 by a, but because it is multiplied by 5, so 25 by 2. Okay. Here you can see e to the power minus 2 mod t, e to the power minus a mod t has the energy 1 by a. Okay, so it is 1 by 2. Energy should come 1 by 2, but because we are multiplying with 5, so here the 5 square will get multiplied. So this is 25 by 2. So again, it is both sided. So 1 upon a, the coefficient here is 1. So 1 by a directly. Okay. So for a rectangular signal, it is easy to calculate the energy. because the limit is very simple, minus t by 2 to t by 2. So it is a square, and then you just need to integrate it. Okay, so what you can do for a rectangular signal, square the amplitude and multiply with the width of the signal. No, this is the energy for the triangular signal. So remember the energy content of the triangular signal. If this triangle is complete, this is a complete triangle, and then its energy is a square by 3 into 2 tau. That means you can say that 2a square tau by 3. 2a square tau by 3. And this 2 is coming because of this width. This complete width is 2 tau. So you are getting the 2 tau in the bracket. If the width is tau, here you can see that this width is tau, then you are getting tau only in the bracket. So for a triangular signal, the energy is 2a square by 3. 2a square tau by 3. Energy content of a half sinusoidal, it is like a, uh, if there is a power, suppose this is a sinusoidal signal. So power of a sinusoidal signal is a square by 2. but the power is equal to energy divided by time. So you want to calculate energy is the power multiplied with time. So the time is nothing but a t. The time duration is t. So a square by 2 into t. So this is how you get this value of power. Now this is the signal. This is a rectangular signal. What is the energy? A square into t. Simple. A square into t, 6 square into t, 20, 720. Symmetrical rectangular pulse. Directly you can calculate. This is also a rectangular pulse. Shifting does not change the energy. Shifting operation does not change the energy of the signal. So this is not a symmetrical about origin, but still the energy will be a square t. So 4 square into width. 4 square into width, 20. This is also same. Shifting, because it should have like this. We are expecting the rectangular pulse like this, for which we know the formula a square t, and it is shifted. So still it is a square t, because shifting does not change the energy of the signal. So it is 3 square into width. This is complete triangular. So 2a square by 3 into t. So 2t, and the width is 4. This is again the triangular shifted. The formula will remain same. Triangle shifting does not change. So whether it is a triangular, rectangle, no, it doesn't matter. This is also triangle, complete triangle. So same 2 a square by 3 into t. T is where it is. Here you cannot say that the t is 0. T is, you can take as a symmetrical, the width, half width is t, half width is t, half width is 4 here. So 2 into 5 is square divided by 3 into half width is 4. So 8 into 25 divided by 3, 200 divided by 3. T means half width. Next, this is a half triangle now. So now this time a square by 3 into half width. So a square 10, 10 is square divided by 3, half width is, this is the complete half width, because if it is full width then it should have like this. But it is 22. So 22 is the half width here. Minus 10 to 12 is the half width. Now you can see that energy for the different signals. So energy of xt is E, then x of t minus a, not change, not change, not change. Shifting does not change. Scaling multiplied by a square. If you suppose change the width, it is divided by a. If you suppose fold, does not change, because we take mod. So if you perform the amplitude folding, there is a minus sign. So when you take mod, this minus sign will get cancelled. So scaling divided by a, and if your amplitude is scaling, then it is multiplied with a square. GT. So scale here also I just wanted to tell that gate 2024 question was this one. X of t has energy E. Then they asked us to calculate the energy of minus 2x 2t plus 3. So this shifting does not affect, this will affect by 2 and this will square. So this will be square, that is 2 square is 4 and this will divide by 2 so that energy will get double. Similarly here, GT is having the energy E, so this G3T will have energy E by 3. If you know the properties, then you can directly tell. If FT has the energy E, then F2T will have energy E by 2. No doubt. Now here you can check once. Consider the following statement regarding the discrete time signal where x of n is equal to minus 1 to the power n u n. So this is x of n minus 1 to the power n un means alternate plus minus 1 only for the positive side. So xn is periodic, no chance because there is no negative value of n. So not periodic signal is not existing between minus infinite to infinite. As initially I told you that for a signal to be periodic, it must exist between minus infinite to infinite. Now the power of x of n, power we can calculate, yes, power 1 limit n tends to infinity 1 upon 2n plus 1 summation n equal to minus capital N to minus n to capital N, right? So mod of x n is square. So when you put the values 1 square, 1 square, 1 square, 1 square up to infinity, so the energy will get infinity. Okay, so energy will get infinity. Only this part will be energy, and this when you add this part, that will become 1 upon 2 to the power n plus 1. And when you square it, minus 1 to the power 2n, so you will get n equal to 0, 1, 2, and so on up to n plus 1 terms. And because there is a 2n plus 1, so you will take n common and you will get 1 by 2 as a power. So energy is infinity and power is 1 by 2. So a power is finite, so it is a power signal. Okay, the formula for the energy is summation n equal to minus infinity to infinity x of n mod square. So when you put the limit n equal to 0 to infinity, x of n means minus 1 to the power n whole square. So it is minus 1 to the power 2n. So when you put n equal to 0, you will get 1. When you put n equal to 1, you will get some minus 1. Minus 1 is square. So you will get again 1 because it is even multiple now. So you will get again 1, then 1, then 1, and so on up to infinite. So it is infinity. Okay, so energy is infinity. Energy is infinity, power is half. Now here I have calculated this only for un. 1 plus 1 plus 1 up to so on up to infinity. Energy is infinity. Power you can calculate and you are getting power 1 by 2 because of the denominator. And there is one more reason that we are getting the finite power because the limit also limited from minus n to n. In the energy it is 0 to infinity, but in the power it is minus n to n. So that is why the energy is going up to infinity and giving us the infinite value, but the power is not infinite. Now try this one. Okay, so here you can see that if you want to calculate the energy of the signal, then suppose we want to calculate the energy of the complete signal, then this is the half triangle, half width is 2. So A square by 3. Okay, so A square divided by 3 into T, because the half width is 2. So like 25 by 3 into T. Similarly here and here. Here is also the same half triangle and it is rectangle A square into T. So when you add them, you will get 183.3. So energy of the cylinder is 183.3. Energy of 2 yt by 3. So this is 2, so 2 is square because it is amplitude scaling. The scaling, time scaling is 1 by 3. So energy will get divided by 1 by 3. So when you will get divided by 1 by 3, it will multiply with 3. Okay, so the 550 by 3 is the actual energy. So this is actual energy. Now you will multiply it because of amplitude scaling, so it is a square. Because of time scaling, you will divide it by 1 by 3. So when you will divide it by 1 by 3, it will get multiplied with 3. So it will get multiplied with 3. So you will get this. Similarly, the same thing you can apply 3 square. Here you will get 3 square. Divide it by 1 by 2, multiplied with 1 by 2. The answer is. Now, xt has the energy 12. So 2xt will have 4 into 12. 3t will have 12 by 3. T minus 4 will have same energy. 2 into 2t multiplied with 2 square and divide it by 2. Simple. So all these properties, if you remember, then it is very easy for you to solve the questions of energy at least. Okay, then I think it is almost done. Now, when you pass it to the differentiator, energies. Yes, this is the get to the 15 questions, so you can check this out. So it is given that these two signals are having same energy. So E1 is equal to E2. So what is the energy of first one? So because this is a to the power n, so you can calculate the energy of previous second one first because it is easy. The x2n is only defined for 0 and 1. So n equal to minus infinite to infinite x2n mod square. So when we put n equal to 0 and n equal to 1, we will get root over 1.5 square, root over 1.5 square. So energy is 3. Now we calculate the energy for the first signal. So it is 0.5 n. So it is 0.5 n square. So it is alpha square, zero point 0.5 square n. When we put the different values of n, because of un, it is only varying from 0 to infinity. So it is 1 plus zero point 0.5 and so on. So we are getting 1 upon 1 minus zero point 0.5 square, which is 1 by 4. So here alpha square upon 1 minus 1 by 4 equal to 3. We will get the value of alpha, which is 3 by 2. This is the same type of signal that we did. This is a trapezoid and you have to calculate the energy of this trapezoid. So the energy of this half triangle is a square by 3 into t. So this is a square by 3 into t, which is 1 by 3. This is a rectangle, so a square into t, which is 1 square into 1. And this is again a square t by 3. So 1 plus 1 by 3, 2 by 3, 2 by 3 plus 1 is 5 by 3. So our answer is 5 by 3. 2018, 2 marks. Just you need to understand how to draw this signal, and that we have done in the previous. Now our next session will be this is the not the actual time. The next session will be announced by the sir, and that will be told to you in the group. So I hope that you have understood each and every concept of the uh, energy and power signal, and periodic and non-periodic, and causal non-causal. So these are the three main type of signals. So we have revised all these three types, and now in the next class we will start systems. Okay, in the next class we will start systems. Even signal or signal, this you can do by the PDF itself, because this PDF will be shared to you. But because we have less time, so this is not that important. As I told you, that only the three type of classification are important: energy, power, causal, non-causal, periodic, non-periodic. If you have understood these three, then you are okay. You can move forward. If you have less time, you can left those topics. But if you suppose want to continue, then you have the PDF access. I hope, and you can learn it by yourself. Thank you.